Astronomers have just made a groundbreaking discovery that could change everything we know about black holes. They found a supermassive black hole in the Large Magellanic Cloud, a dwarf galaxy orbiting the Milky Way, and it's heading straight for us. This discovery is far more than just a cosmic curiosity. It has huge implications for understanding how black holes grow, evolve, and interact with the galaxies they inhabit. But how did they find it? And why is it so important? Let's break it down. Unlike stars, black holes don't emit any light, so they're invisible to our eyes. But scientists have found clever ways to detect their presence. They study the gravitational effects black holes have on nearby stars, gas clouds, and other objects. In this case, astronomers used an ingenious method by tracking hypervelocity stars. These stars are rare and move at incredibly high speeds, much faster than normal stars. And they don't just zip around for no reason. In many cases, they've been flung from their orbits by something massive, like a black hole. This happens through a process called the Hill's mechanism, where a pair of stars in a binary system gets too close to a supermassive black hole. The intense gravity of the black hole tears the pair apart, capturing one star and slingshotting the other at incredible speeds. Using data from the Gaia Space Telescope, which has been mapping the precise motions of billions of stars, researchers discovered that 9 hypervelocity stars in the Milky Way originated from the Large Magellanic Cloud. These stars shouldn't be moving that fast unless something incredibly massive kicked them out. After a detailed analysis, scientists concluded that the culprit was a supermassive black hole with an estimated mass of 600,000 times that of our Sun. This discovery is huge because it suggests that the LMC has a supermassive black hole at its center, a question that scientists had been uncertain about before. The existence of this black hole helps fill an important gap in our understanding of black holes. We're familiar with stellar mass black holes, which form from collapsing stars and have masses of a few to tens of times that of the Sun. We also know about the giant supermassive black holes that exist at the centers of galaxies, like Sagittarius A*, the one in the center of the Milky Way, which has millions to billions of times the mass of our Sun. But mid-size black holes, like this one in the LMC, are much rarer and harder to find. If confirmed, this discovery could help scientists understand how black holes of this size grow and evolve. Do they feed on gas and stars to eventually become even larger? Or do they merge with other black holes during galaxy collisions? These are the types of questions that make this discovery so exciting. The Large Magellanic Cloud has been orbiting the Milky Way for billions of years, but it's not just peacefully coasting by. In fact, it's on a collision course with our galaxy. In about 2.4 billion years, the LMC will collide with the Milky Way, causing major changes to our galaxy's structure. But what happens when a galaxy with a supermassive black hole crashes into another galaxy that already has one? When the LMC merges with the Milky Way, its black hole won't just disappear. Instead, it will begin sinking toward the center of our galaxy, pulled by gravity over millions of years, getting closer and closer to Sagittarius A*, the supermassive black hole that already resides there. As these two black holes approach each other, they will begin to orbit each other, forming a binary black hole system. Over time, the gravitational waves, ripples in space-time predicted by Einstein, will carry away energy, causing the black holes to spiral closer together until they finally merge in a spectacular explosion of energy. This process has been observed with smaller black hole mergers by gravitational wave observatories like LIGO and Virgo. But seeing this happen with supermassive black holes in our own galaxy would be a once-in-a-lifetime event. But the collision of the LMC and the Milky Way won't just be about black holes. The LMC is bringing with it stars, gas, and dust. When it merges with the Milky Way, this could trigger new waves of star formation. In fact, some scientists believe this event could even change the structure of our galaxy, possibly transforming it from its current spiral shape into something more elliptical. While this event is far in the future, studying it helps us understand how galaxies evolve. Mergers like this aren't rare. Many galaxies we see today are the result of past collisions. The Milky Way itself is expected to collide with the Andromeda Galaxy in about 4.5 billion years, so the LMC collision could serve as a preview of even bigger things to come. To fully understand the importance of this newly discovered black hole, it helps to look at some other famous supermassive black holes in the universe. These well-known examples give us insights into how black holes form, grow, and affect their galaxies. One of the most famous is Sagittarius A*, the supermassive black hole at the center of our Milky Way. We know it's there because of its gravitational pull on nearby stars, which orbit it at incredible speeds. In 2022, the Event Horizon Telescope captured the first ever image of Sagittarius A*, confirming its existence and providing a new way to study these mysterious objects. Another legendary black hole is M87, located in the center of the giant elliptical galaxy Messier 87. This black hole is a true monster, with a mass of 6.5 billion suns. In 2019, it became the first black hole ever imaged, showing a glowing ring of light surrounding its dark center. And then there's TUN 618, one of the largest black holes known, with an estimated mass of over 40 billion solar masses. It's found in a quasar, an extremely bright and active galaxy, where it's constantly feeding on surrounding gas and creating massive jets of energy. What do these black holes teach us? They show that black holes don't remain the same size forever. They grow over time, either by eating surrounding material or merging with other black holes. If the LMC's black hole merges with Sagittarius A*, it could kickstart the growth of our own supermassive black hole, potentially making it as massive as M87 over billions of years. As we look to the future, the collision between the LMC and the Milky Way will provide us with a front-row seat to witness a cosmic event that could change the very structure of our galaxy. Understanding how these black holes evolve will not only deepen our knowledge of these mysterious objects, but it will also help us unlock the secrets of the universe itself.